Okay, next bit, we need to add some friction to inclined planes. So we have a particle of mass 2 kilograms sliding down a rough slope, so that's telling you there's some friction, inclined at 30 degrees to the horizontal. Given that A equals 1 metre per second squared, find mu. So you should be able to do a sketch from there without any problems. So we have the slope, inclined at 30 degrees to the horizontal, and the particle is sliding down the slope. So I'm going to take that as my positive direction. So positive direction, direction of motion. We have reaction force acting perpendicular to the surface. The frictional force opposes motion, so that will be parallel to the surface. And then we've got weight acting down, no other forces. We're looking to find the coefficient of friction. So we're looking at resolving either parallel or perpendicular to the slope. If we resolve perpendicular, we can find this reaction force. So resolving perpendicular. So the motion's parallel, so the perpendicular forces are in equilibrium. So R, acting that way, is going to equal 2g cos 30. So if I draw a triangle in there, like so, this angle in here is 30 degrees. Force is on the hypotenuse and we want the adjacent. So 2g cos 30 gives you that adjacent. That comes out as being 16.974, but again, I would think about popping that and storing it as x on your calculator as you work through. Now if I resolve parallel, I've just realised I've put in a vertical there, that's meant to be a perpendicular. So that's perpendicular to the surface, parallel to the surface. So resolving parallel, because the motion's parallel, you're really looking at having a resultant force which equals mass times the acceleration, unless it's in equilibrium, in which case the forces will balance, but otherwise there will be a resultant force and there'll be some acceleration. So we're going to use F equals ma. So acting down the slope, I've got this component here in this direction, which is my positive direction. So that's 2g sine 30. Minus the friction, which is acting in the opposite direction, is equal to ma. M is equal to 2 and A is equal to 1. And so from there, the frictional force comes out as 7.8 newtons. That's exact actually for that one. Although G is rounded to 2 sig figs, it's not, not too exact. So we've got R, we've got F, we want mu. So it's moving, so we're at maximum friction. So F max is equal to mu R. Then 7.8 is equal to mu times 16.974. But if you've stored that to x on your calculator, then you can do 7.8 divided by x to get to mu. And then you can be pretty confident you haven't got a rounding error. So mu comes out as 0.46, and that's to 2 sig fig. So I've set just a couple quite similar ones to this, and then we'll look at putting another force in here as well, then that's probably enough for today.